everyone. Today we are going to discuss historical number systems, and we're going to begin with the Egyptian system. Before you continue further in this video, I would recommend that you look at this YouTube video, A Brief History of Numerical Systems by Alessandra King. I believe it's a TED Ed video, and I think it gives a great overview of some of the different historical number systems and why some are improvements on others, which we'll also try to discuss in this video as well. Now, whenever we talk about our number system, a vocabulary word you'll want to be familiar with in this chapter is the idea of the Hindu-Arabic system. That is our number system. So if you ever see a Hindu-Arabic system, just think of that as our numbers. It is base 10. We write them and they've got representations in terms of place value that we'll talk about later, but just keep that in mind. So based on preserved documents that we found from previous civilizations, we've been able to piece together some different number systems that have existed throughout world history. And let's start with the Egyptian symbols. So for the Egyptian symbols, we've got these various symbols that we are going to be working with. And in order to express something, for instance, if we wanted to express 12, I would write 1, 2. And as a brief aside, our number system is what is called positional, which means it matters what place the digit goes. Because, for instance, we know that there is a difference between 1, 2 and 2, 1. It's formed by the same characters, but the order and the placement of those characters gives a different meaning, because we know that the first digit to the right is always the ones place, followed by the tens place. So whenever we see 12, what we've interpreted in our mind, just because we're so familiar with our number system, is that I've got one set of 10 and then two sets of ones. Whereas if I was looking at 21, I would say, well, I've got one set of ones and two sets of tens. But the Egyptian system is not positional. So if we wanted to represent 12 in the Egyptian symbols, we would want to look, and we see that to represent a 10, we do this upside down U. So if I write that, that means 10. And then to get to 12, I also need two ones, based on our understanding of 12. And for the Egyptian symbols, you would just write 2 of these lines, because each line represents 1. And this would be the number 12. It would also be the same number 12 if we wrote it like this, but just convention has it that you usually go from larger numbers to smaller numbers, left to right. So with the Egyptian numerals, if you wanted to express a larger number, you would need to use more symbols. So for instance, if we change our example, and instead of 12, we say, let's now write maybe 156. We know that we need 1 100, 5 tens, and then 6 ones. And with all of the videos that we're having in class, remember, I'm going to introduce ideas, and then it's a good time for you to practice the ideas. So in our lecture videos, I'm going to have a time where I would say, now pause the video. And during the pause the video, you should pause, work out the example on your own paper, and then after you've worked out the example, unpause, and I'm going to talk through the solution. And in that way, you get immediate feedback, whether you're understanding the current material, you get to practice that. So if you pause and then unpause and you did not get the right answer, see if the solution helps clarify what went wrong. And if you're still unsure what went wrong, feel free to just take a picture of your work and send it to me, and then I can see what you were doing and maybe pinpoint and offer some clarifying ideas. So if you would, take a moment to pause the video and write 156 as an Egyptian numeral based on these numerical symbols. Unpause when you're ready to check your work. Okay, great everyone. So we're going to write 156. I'm going to start with the largest number. We need to account for 1 100. So I look at the symbols, and these symbols will be provided on any exam, so you don't have to worry about memorizing them. And we see it's this squiggle here, this spiral. So I'm going to write 100 by writing the spiral, just as long as it's distinguishable. Okay, we've got that taken care of. And then I need to write the fact that I've got 5 tens, because this is in the tens place. So I'm going to have 5 of these heel bones because each one is 10. And with the Egyptian symbol, sometimes they stack it just for space. For instance, if I write 5 in a row, that's totally fine, but it would take up more space, so you could just write them like this. It means the same thing. We got the 5 tens, and then we need 6 ones. So I'm going to have 6 ones, and again, if I want to, I can stack them just to take up less space. And this represents 156 in the Egyptian numeral system. Now, we just did an example where we took something that was in our numerical representation and translated it to Egyptian. This next example has kind of the reverse problem. In this next example, we are going to go from already Egyptian symbols to our number system. And really quickly, I apologize for that typo. I'll make sure I correct it on the printout notes that I post to the classroom. In a previous version of the book, they used a slightly different symbol for 100,000, but for our book, this is the symbol, so I've just corrected my example to show the little tadpole instead of the thing that looked more like a whale. So now that that's corrected, we want to translate this Egyptian symbol into our own number, and notice they said Hindu Arabic number. That's our number system. So let's start from the left and then go to the right, because we know we write usually larger to smaller. This symbol matches this, so we know each one of these represents 100,000, and since we have 2 of them, that means we have 200,000. And if you want, you could just write it out at first where you're just going to be adding them all together. The reason I have 200,000 is because I have 2 of the 100,000s. Next, we identify this symbol. The next symbol here, these little flower types, represent 1,000 each, and we'd count how many of them do we have. 1, 2, 3, 4. So we've got 4 of those, so that represents 4,000 that we're adding. Next, we would translate the symbols to the right of that, and we see that matches our scroll. Now we have 3 of those symbols, each of them 100. So we would add 300 to that. And then we would continue with our next one. Now here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of the heel bones. Each of them are 10 each. So that means we have an additional 90 represented by these symbols. Finally, we've got our ones. 1, 2, 3, 4, 5, 6, and we have 7 of those. So that means we're going to add 7. Now add these all together. You can either add them in your calculator or just mentally think about it, and we would get our final answer to be 200,000 or 204,397. So this number in Egyptian numerals represents our Hindu Arabic number of 204,397. Now this is just another example to practice taking Egyptian symbols into our number system. So here we've got this written, and this isn't in the notes, this is just one you can write off to the side as an extra example. If you would pause the video now, translate this into our number system, and then unpause to check your work. Now here we just start from left to right and we look, what is this symbol representing in terms of our number system? We identify each one of these symbols represents 10,000. Since we've got 3 of them, that would represent 30,000 because it's 3 10,000s. And we are going to add to that 2 of these symbols, each of which represent 100. So that combines to be 200 that we're adding, plus these symbols, we see that represents 10 each, and we've got 1, 2, 3, 4, 5, 6, 7, 8 of those. 8 times 10 is 80. Add that all together and we have 30,280. And in this part, you could either just add these together in your mind, knowing how the place values work, or you could carefully type them into your calculator and you would get the same answer. So if you got that right, great job. If you didn't get that right, maybe look over your work and try to identify why the correction is necessary. And if you're unsure, remember you can always take a picture, send it to me along with your question. I'll be happy to get back to you. Now in this next example, we are asked to express something that is an R number system into Egyptian form. And this can be a helpful time just to review how our number system works. At the farthest right of any number that we write is always the ones place. And then as you move over one digit to the left, you keep increasing the place value as a multiple of 10. So at first we've got the ones place. And then as we move over to the next position, we have the tens place. And then next, 10 times 10 is 100, so we've got the hundreds place. Moving over again, we increase by 10, so 10 times 100 is a thousands place. That's why this is the thousands, the 10,000, and the 100,000s. Now, I think the easiest way to think about it is just not to stress about it too much, because you've been working with these numbers your whole life, so you kind of have just this inherent knowledge about them, where if I asked you to read this number out, you would clearly call it 300,000 or 376,248. So we would know how to express this number if we were just asked to read it. And just by reading it out verbally, it can help us keep in mind the placeholder. Because whenever we say 376,000, I want to draw your attention, this was our compound statement. It's 300,000 plus an additional 76,000. To represent 300,000, you would first look at the Egyptian symbols, because we are going to Egyptian form. And looking at these symbols that I just brought off to the side, we would see to express 100,000 in the Egyptian symbol, you would have to write one of these tadpoles. Well, how many 100,000s do we need? We need 300,000. So to express the 300,000 part, we would just write 3 of these tadpoles. And again, the location of the tadpoles does not matter in the Egyptian symbols. And if we want to save space, we can write them over each other. And that takes care of this portion of our verbal expression of this number. Now there's another part of this combined statement, because it was 376,000, all of that was together as we would read it through. So we also have to account for the 70,000 part, which we would see here because it's in the 10,000s place. We know to represent 10,000, you would have to look like this. And how many of those do we need? We need 70,000, so it's 7 of those. So we just need to write 7 of these symbols there. And with that, we've taken care of the 70,000 part. Finally, whenever we were expressing this verbally, we did say 76,000, so we need to express that idea of the 6,000. Now when we've got the 6,000, which comes from this digit here, we need 6 1,000s. We see 1,000 is expressed by these flowers, so we're just going to write 6 of them. Now as you're writing them, you might want to just start with the triangle base, then go straight up. Any way is fine. This is just an efficient way I found. And we want 6 of those, so I'm just going to make 2 stacks of 3. Okay. Great. And that takes part of the first part of the statement. We have expressed the fact that we have 376,000. And now we just need to finish the second part of our number, which is 248. Now, continuing that, we know we have got 248, so we're going to look at the 100s. We have, to represent 200, you just need to write 2 of these spirals. And there we've got the 200. Now we need to look at the fact that we need 40. To write 40, each of these is a heel bone, so we just have 4 of them. That's our 40. Finally, to represent 8, our last digit, we just want 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. And here we have expressed 300,000, 70,000, 6,000, 200, 40, and then 8, added all together, gives us 376,248. Now, just for additional practice, why don't you take a moment to write 20,320 in Egyptian numerals? And for this, I recommend you would pause the video now, do the problem, and then unpause to check your work. Now with this, whenever we read this number, we would call it 20,320. To get 20,000, we need two 10,000s, which we see we've got here. So that's our 20,000. And then we've already accounted for the first two digits because 20,000 is just two 10,000s. So next we look at the 300. To express 300, we just need three 100s. So we had three spirals. We've got the 300 taken care of. To express 20, we just need two tens places, and that's it. So this is our 20,320 in Egyptian form. Now in this example, we're just going to practice subtracting Egyptian numbers from each other. So we've got our first Egyptian number written in the top, and we are subtracting the second Egyptian number. And while you could translate each Egyptian number to our number system, subtract them, and then write the symbols back, I think it'll be easiest just to think about it how we normally would. We're going to take away from the top number what we see represented in the bottom number. So first, we are going to worry about subtracting the ones from the bottom number from the ones we see represented in the second number. So in the bottom number, we've got 4 ones represented, and we are going to take those away from the top number. So we've subtracted equal amounts from each other. What we're left with is 3 ones. So we write that below. Next, we give our attention to the tens place. In the bottom number, we have 1 10, and we are going to take that 1 10 away from the tens in the top number, which would leave us with 3 tens remaining that we write below. Similarly with our spirals, which represent 100 each, in the bottom we've got 3 such of those spirals, and then we are going to take those 3 away from those in the top, and we are left with only 2 spirals remaining, so we express that, and that would be the solution to this subtraction problem here. And there is no meaning behind the change of colors in our final answer. I just forgot to change the pen back to black. So for this next example, we're going to do the same thing, except we notice whenever we try to take away the 4 ones that we've got represented in the bottom number from the ones in the top, as we take away 4 of them, we've only got 2 to get rid of at the top, which leaves us with a deficit. This is kind of whenever you would subtract, maybe for instance, 12 minus 4. What do we have to do? There wasn't enough ones in the top number, so we had to borrow so that we could take away. Now there's 12 ones that we subtract 4 and we only have 8 left. We're doing the same thing just with these symbols. In order to have enough ones to subtract, we first have to get rid of one of these tens, but we can't change the number. So if I'm getting rid of the tens grouped together in this symbol, I need to give 10 ones in its place. So this symbol of tens got redistributed, or not redistributed, it's still in the same number, it's just re-expressed as 10 ones. So it's the same number, just expressed differently. So now whenever we get rid of the 4 ones from the bottom number, we've got those 2 to go, and then those 2 to go, and we're left with 1, 2, 3, 4, 5, 6, 7, 8 ones left. We write those 8 ones below. Okay, and now here we've got, for the tens that we're subtracting next, we've got 2 tens below, and if we subtract those 2 tens, we take them away from the bottom, we take an equal away amount from the top. Remember that this 10 is gone previously because it's what gave us the 10 ones here. So we take the 2 tens away from the bottom, take that away from the top, and we're left with just 1 10 remaining. Similarly, we've got 2 of the spirals, each representing 100 at the top, 1 of the spirals at the bottom. Whenever we take this 1 spiral away, From the top and bottom, we're left with 1 remaining. And that would be the solution to the subtraction problem in Egyptian numerals. Our next historical number system that we're going to look at is Roman numerals. Now with Roman numerals, we've got these symbols. Again, the symbols will be given on any exam, so you don't have to worry about writing them down, you just need to know how to work with them. And let's quickly talk about some special features of the Roman numeral system. So the Roman numeral system has symbols for 1, 10, 100, and 1,000, and then nicely it has extra symbols to represent 5, 50, and 500. This allows less symbol representation or symbol repetition within a numeral. So for instance, if I wanted to write 15, instead of writing 110 and 5 ones, I could write the symbol for 110 and then 5 as a symbol, because we now have the grouping symbol for 5s. Now, a subtractive feature, this is probably the key distinction of our Roman system, and we might have already been familiar with it just by the Roman numerals that we've seen in our daily life. For instance, if we saw the Roman numeral, it looks like a 1 and then a V, that represents the number 4, whereas a V and then an I represents the number 6. And the reason behind this is just this idea of the subtractive symbol. So in the Roman numerals, the line is the 1, the V is the 5. And notice in the representation that represents 4, we have the 1 symbol coming before the 5 symbol. So this is a little strange, right? We've got the smaller number to the left of the larger number. And in the Roman numeral system, if you ever have a smaller symbol that comes before, i.e. to the left of a larger number, that means you subtract them. So the Romans would have read this as, since the 1 comes first before the 5, 5 minus 1, which gives us our 4. Whereas in this number system, in the next one that represents 6, notice the 5 comes first, as expected, bigger numbers first, then followed by a 1, and that just represents, if the order is not mixed up then, it would just be 5 plus 1. And that's called the subtractive feature. So if you have a smaller valued symbol placed before, which is immediately to the left of a larger value, that means subtract the two symbols. And you can't write any Roman symbols in this way. There's a few that go together with this subtractive feature. The ones number can only be in front of a 5 or a 10 digit. You couldn't put a 1 in front of a 100 digit to represent 99. That just wasn't done. The X, which is the tens digit, could only be in front of a L or a C. A C can only be in front of a D or an M. So only certain digits can be placed in front of certain other digits under the subtractive feature. And if we wanted to represent a larger number, it has the multiplicative feature, which means that if you have a bar over an entire number, that just means multiply that by 1,000. So it's whatever the number you see represented times 1,000. Let's look at the Roman numeral symbols. So we've got our symbols here, and let's first translate from our number system to Roman numerals. Now, if we wanted to write 6 as a Roman numeral, we could write 6 ones, but why not take advantage of the fact that we've got larger symbols that we could write a 5 plus a 1, right? 6 is 5 plus 1, so we'd have the symbol for 5, and then the symbol for 1, and since it's larger and then smaller, that works, you would add the values together. Now to represent 12, we know we've got 1 10 and then 2 1s. So we would take the symbol for 10, and that accounts for the 10, and then we have 2 1s, 1, 2, and that would be 12. Now for 49, while we could write the 40 and then 9 1s, we could use our subtractive feature to write the number 9, because if I'm just writing 9, I would take the symbol for 10. It says go to 10. You're almost at 10, right? How far away are you from 10? 1 away. So if you just write the 1 in front of it, that represents 10 minus 1, which is 9. If you could, just for practice, think about what is x 1 represent? If we've got our X and then the 1 symbol. Since it's 10 and then a 1 symbol, we're going from larger to smaller, so that would represent the number 11 because we add the digits. Whereas if it's smaller and then larger, you subtract them. So for 49, along with that discussion, I recommend you would pause right now, express 49 in Roman numerals, unpause to check your work. So with 40, we might want to write X, 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 which represents 4 tens, which is 40, but there's a faster way to do this. 40 is 10 away from 50. So if we write our symbol for 50, and then we write a 10 in front of it, by the subtractive feature, we know that has to represent 40, because it's 50 with a 10 in front, so that means take 10 away from 50, you'd get to 40. And that's going to be a lot more efficient than writing 10 X's. So we're going to start with XL, and that takes care of the 40. And then we also have to account for the fact that there's 9 ones. So to write 9, we get to 10 in X, and then we just take away 1. With the subtractive feature, we put the 1 symbol before the 10 symbol. And if you were reading this, the way you would know that this is 49 is you would always start reading from the left going to the right. So start here and just translate the symbol. This is the symbol for 10. The next symbol is the symbol for 50. And then we'd say, oh wait, a 10 comes before the 50? That's out of numerical order. That means in this symbol, we would need to subtract them. It's really 50 minus 10. So these first two symbols represent 40. Keep reading. This is the symbol for 1. This is the symbol for 10. Again, we've got this out of order, which means we are subtracting them. So it's 10 minus 1, which would give us plus 9. Add that all together and we get 49. So this is a translation that used the subtractive feature twice. Now for 75, we would think about how could we most efficiently get to 70, because that's going to be 70 plus 5. We know easily how to represent 5. 5 is just the V. So we just have to be able to represent 70. We don't want to write the X's 10 times. That would take a lot of space. Or sorry, 7 times, right? Instead, why don't we get as close as we can to 70? So notice 70 would be between 50 and 100. We don't want to overshoot it. So we're going to say we've got 50. How many left do we need to get to 70? 20, right? So we'd write 2 X's. And that's going to be 70 because it's 50 plus 20 or plus 10 plus 10, 70 there. So we would write this as 70 and then a 5, 75. Now for 101, we look at the numerical symbols that we've got. We could get to 100 by just writing a C. We still are lacking 1. Since we want to add that 1, we would write that to the right. So it'd just be C1. So this was taking our numerical symbols to the Roman system. Now let's take the Roman system to our number system. And this is our first example here. I would just go by translating these one at a time. Looking for C, that's 100. Okay, D is 500. And here I'm alert because this means that I've got the subtractive feature, right? Because I've got smaller before larger. That means you would take the 100 and subtract it from the 500. So that would just give me 400. Okay, let's keep translating. The L represents the 50. The X represents the 10. Okay, so far so good. It's going from larger to smaller, so we would add those. That adds us to be 60. I'll kind of keep that together. And then we've got the V represents the 5. And the 1 represents the 1. These are in the correct order, so we would add them, larger to smaller, and that would give us plus 6. And you don't have to show all this work. I'm just doing it as an example. You could, as you get comfortable, just think about it, whatever works best for you, and we would get 466. Now, if you would, for our next one, take a moment to pause the video, translate it, and then unpause to check your work. As as we just translated each symbol one by one, I just wrote it above. We've got a 500, 100, 100, 50, 10, 10, 10, 5, 1. Now, as I'm reading right to left, I'm going to see, are any of these out of order? No, they're always going from largest to smallest. So that means we would just add all the symbols that we see represented together. So that would be 500 plus 200. That would get us to 700. 50 plus 10 plus 10 plus 10 gets you to 80. And then we've got 5 plus 1, which is 6. That would be 786. Now for this next one, I see I've got 1,000. The D represents 500. The L represents 50. The X represents 10. The L represents 50. And then 5, 1, 1, 1. Now, as we see this, we've got the first two, the M and the D, represent 1,000 plus 500. That would be 1,500. And then continuing, we've got 50. As we were working through this, I realized there was a typo here. I did not mean to type this additional L. So it should read MDLXVIII. So continuing now with that corrected version, we've got a 1,000, a 500. Since those are in correct order, we could link those together to give us 1,500. Continuing, we've got a LX. Now an LX, an L is 10, an X is 50. Since they're out of order, smaller than bigger, we know we're going to subtract them, so that adds 40. And then we've got the 5 followed by 3 ones. That would add 8, and that would be 1,548. As our answer, again, no need to show this work unless you find it helpful. You can also just read it from left to right as you get comfortable with this system. Now we're going to start with the Chinese numerals, so that finishes us for the Roman numerals. In Chinese numerals, they would write from largest number down. So we've got our largest number in kind of like our base 10 down to smaller number. And it's also written in pairs in a certain way. Now with these pairs, it's always going to be one symbol on top of another symbol, and they're just written vertically. And the way it's going to be written is the bottom grouping of the symbols. So for instance, in a pair, the bottom numeral is always going to come as a multiple of 10, and the numeral that is above it is going to be in the ones places, so any of these. And the way you would read it is kind of this multiplicative. You would first translate, okay, what one symbol is this? Looking at our list, it looks most like this, which is a 5. So we would read this as 5 times what base 10 symbol is this? It looks most like the 100. So we'd read this as 5 times 100, which is a very quick way of writing 500. So instead of having to write the 100 symbol 5 times, the Chinese numeral has a way to express this multiplication through these very nice quick pairs. So remember, with these pairs, you would write the ones number first, followed by the multiplier of 10 that you want. So if we were trying to write 500, I would have 5 100 symbols. So let's translate our first number into the Chinese number system. If we're writing 614, it will help us if I can think about it as, okay, I've got 6 100s plus 1 10 plus 4 ones. And to express that, you would start with the largest grouping, so 6 100s. I would write, starting from top, going straight down, I need to write the fact that I've got 6 100s, so looking for the symbol of 6 here. We've got that. And just write it to the best of your ability. As long as it's distinguishable, that is fine. That represents that I've got 6 What do I have 6 of? 100s. So looking for the symbol of 100, we would write that. And this takes care of the idea that we've got 6 100s. These are paired together in those grouping. Continuing, we've got 1 10. Next, we've got 1 10. So we'd write the symbol for 1. Showing that it's 110, we would write the symbol for 10 following it. And then finally, for just the ones place, you would just write the 1 symbol with no pair attached to it. So the ones is the only one that's not written in a 2-part pair. The symbol for 4 is just this, so we'd write that. And that is 614. And the way you would read it is starting from the top, pairing it off. We would express this as 6 times 100 plus 1 times 10 plus 4, 614. Great. So for the next one, we are going to write 4,628 as a Chinese numeral. If you would take a moment to use the ideas that we just talked about, how you start with the largest base 10 group, in this case 4,000, and then you write it in pairs where you express how many of the tens, hundreds, or thousands do you have, and then just write top to bottom. So pause the video now, work on this, and then unpause when you're ready to check your work. So here we've got 4 1,000s. This is the symbol for 1,000, and I've got 4 of those, so I'm going to start at the top with the symbol for 4. I've got 4 1,000s, so I'm going to write those paired together. That's going to represent 4,000. Continuing on, I've got 600, so that means I've got 6 100s, so I'm going to write the symbol for 6 along with the symbol for 100. So I've got 600. 20, which is 2 10s, so I've got the symbol for 2 along with the symbol for 10. And then 8, we know the ones position is just the one where we write the symbol, there's no pair attached to it. So for 8, it's just this symbol. Great. So we've got these pairs along with the ones place. This would be 4,628. And that's the exact right answer. So we went from our number system to the Chinese numerals. Now let's take Chinese numerals and interpret them into our number system. Now in the first example, remember that we go from top to bottom. And I like to just draw this little bracket to help me remember that these are written in pairs that should be interpreted together. So these two pair together, these pair together, these pair together, and this doesn't have anything to pair with, but that's as to be expected, it's just the ones. And now I just need to translate each symbol. So this matches the symbol for 3. So that means I've got 3 times. Now the next symbol is always going to be one of these multipliers of 10, either 10, 100, or 1,000. In this case, this represents 1,000. So it means I've got 3 1,000s that I'm adding to. Next, this is just the symbol for 1. So I've got 1 that I'm multiplying by 100 that I'm adding to. This, looking through, is the symbol for 6. So you've got 6 that you're getting multiplied by the symbol for 10. And then you're just adding 4 at the very end. So this would be 3,000 plus 100 plus 60 plus 4. So for A, we have 3,164 is our answer. And notice the way we found that is just starting from the top to the bottom, linking them in pairs, translating each pair, and then multiplying them, adding them all together. So take a moment to look at the next one, our example B. I'll give everybody time to attempt it. If you would pause the problem now, attempt your work, and then unpause to check your answer. 1 second, I'll put those back. Okay, now pause. You'll see the symbols on your screen. So here we are just going to start pairing here. These two are paired together. There's only one symbol left. Here we know that this is just the ones place. So this is, the top is the symbol for 7. Since it's in a pair, you multiply it by the symbol for 100. So you've got 7 times 100 that you're just adding. This is the symbol for 3. So we would have 703 as our answer for part B. Now for the next one, we continue as before. We just start making pairs. We see we're left with just a ones as expected at the very bottom. This is the top symbol is the symbol for 5, followed by the symbol for 1000. Since they're in a pair, that would be 5 times 1000 that we are adding to the symbol for 9. So this would be 5000 and 9. And notice in this case for 5009 you don't have any hundreds or tens, so they're just not even expressed as a pair. They're just not written, and then you just follow up with the 9 ones. Now for our last one, I recommend you take a moment to pause the video and just work on it on your own. Unpause to check your work. So we start from the top and go down, kind of linking in pairs. Now in this case, we've got 2 symbols left, so that makes up a pair. And notice the way we know that this is a pair is the bottom symbol in every pair will be one of these 3 multipliers of 10, right? We can see that here in every multiplier of 10 that's in the bottom part of any pair. And in this case, there's no additional symbol written at the bottom, so there's no ones place. That means there's going to be a 0 in the ones place. We see that we've got the symbol for 4, 1000s. So we've got 4 times 1000, which is 4000. Plus, we've got the symbol for 2, and then we've got the symbol for 100. So it would be plus 2 times 100. Altogether, that gives us 4000 plus 200. So 4000 and 200 is our symbol. And notice we've got no tens represented. That's why we don't have a third pair with the tens. And we've also got 0 ones. That's why we don't have just a lingering 1 symbol there. Now the final historical number system that we're going to look at in this lecture is the Greek symbols. And for the Greek numbers, we've got a lot of different symbols, but that's going to make writing the numbers, I think, a bit more efficient, because in that case, you don't have to keep repeating the symbol a lot. You've got symbols for everything between 1 and 9, and then you've got 10, 20, 30, 40, 50, 60, 70, 80, 90, and you've got symbols for 100, 200, 300, 400, 500, 600, 700, 800, and 900. So for instance, if I wanted to write 536 in Greek symbols, all I would do is get the symbol for 500, which we can find, since it's the 500 place, as this. Then I would have to express the idea that I've got 30, so you look for the 30 symbol. And then we need to express that we've got 6 ones, so you'd look for the 6 1 symbol. And that would be 536. So with the Greek symbol, you would just write it down based on that, starting with largest and then going to the right to the smallest grouping. So in these examples, we have something that is written in Greek symbols that we are going to translate into our number system, the Hindu-Arabic form. Starting with our first example, we just need to identify in this large list of symbols what this is. So that's going to be the biggest time-consuming part of this. So looking, we see that matches with the 30. The next symbol, we need to find it, and we see it pretty quick. That's the 1. You might just start at the ones and then just keep going till you find the symbol. So that's going to be 30 plus 1. which is 31. Now let's look at our second example. Again, the trick here is just to find the correct symbol. Why don't you look for this in the table? Pause the video if needed. I'll show the answer in 1 second. We would find it here. So that symbol represents 300. Next, we would find this symbol. And we see it here representing 20. Finally, we've got this symbol. And just another way to help figure this out, if you've got 3 symbols, the Greek symbol starts with the largest grouping first, so that's going to be in the hundreds, then the tens, and then the ones. So that might help you speed this up. You know, if you're looking for this symbol and it's the third from the right, it's going to be in this column because it's going to be one of the hundreds. If you're looking for this symbol and it's the second from the right, that's going to be in the ones, the tens, so you know you'd be looking at this column. And if it's just the first from the right, that's going to be the 1, so you know you'd be looking in this column. So that might help speed it up as well. Putting that all together, we would get the number 325. Now for this last one, I recommend that you would pause the video and look for the number you see represented, unpause to check your work. And here we see that we've got a 600 symbol. And this is the one exception to what I was talking about in looking at the columns. Even though this is the second symbol to the left, it happens to represent a multiplier of 100 because there is no tens in this number. This number is just 604. So in the Greek symbol, notice there's no tens place. When there's no tens place, you just don't write it. So we would just express this as 604. So we've gone from Greek symbols to ours. Now it's time to go the reverse. We're going to go from our number system to Greek symbols. Let's start with 48. Now in 48, we've got 40, which we would write here. And then we would have additionally an 8. And we would write just largest symbol to the left and then smallest symbol after that. So we've got 40. And then 8. Next, looking at 124, that is 100. So we have 100 given by this symbol. And then we've got 20. And then 4. Writing these all together, we would have 100, 20, and then 4. Now for 775 and then separately 39, I recommend you take a moment to pause the video and work on both of these problems. Unpause when you're ready to check your work. For 775, we just need to isolate the 700, the 70, and then the 5 symbols, which we've done here in our table, and then write them in descending order. So we've got the largest 700, 70, and then 5. For 39, we've got 30, followed by a 9. So we would see the 30 is here, followed by a 9, which we've got there. So we just write it 30 first and then the 9. And that's it with Greek symbols. So just to help everybody know how to best use these videos, as you are taking notes on your paper, remember you're watching the screen, you're pausing, you're thinking about it, you're writing down your notes if you want to have a reference later. That could be helpful as you prepare for our exams and do the homework. So next, you're going to look over what you just learned about and you're going to see, do I have any questions? If you do, that's whenever you would send me a Canvas message or an email through our school account and just ask the question that you have, particularly if you've got a moment in the video that you're curious about. You could either take a picture of the problem and send it to me, you could describe it in words, you could give me the timestamp on the video, any of those work. And get your question answered. Now, if you don't have questions and you're ready to get started with the homework, I would say go to your textbook homework problems. All of them are odd, which means you should do a problem and then check your work in the back of the book. Don't go through the whole assignment and then check your work, because you might have been reinforcing wrong answers at that point over and over. So remember, do a problem and then mark the back of the book with the post-it note, check your answer. If you see that it's correct, move on. If it's incorrect, think about, can I correct it? Try to do it on your own. And if you get the correct answer and you're confident in it, move on to the next problem. But if you're unsure why you got the incorrect answer, you're always welcome to send me a picture of your work. I can look at it and give you feedback. After you've done the textbook homework problems, all of this from this section, and you're confident, then you can go to take our section quiz. Now, with the section quiz, for the first attempt, I recommend you would just take the problem, have your notes ready after you've done the textbook homework, and then take the section quiz. Work out the problems on paper, select the correct answer, don't forget to submit quiz at the end. And then, at the very end of that, it's going to show you which questions you got correct and which ones you got incorrect. For the ones that are incorrect, try to work through them again and see if you can get the correct answer. Feel free to send me questions if you have them. And then once you've thought about it and improved your work if necessary, you can take the next attempt of the quiz to try to improve your score. Canvas will keep the highest of the attempts. So if you have any questions, don't hesitate to reach out via our school email or Canvas. Thank you.